Okay, let's do one more video on Locus, as this will give us a good foundation into the next topic, which is conical sections. So the first example, given a point A with the coordinates 1, 3 and a point B with coordinates -2, 5, find the locus of a point P of x, y such that the distance PA is equal to twice the distance of PB. The first step is to always plot the points so we have a good picture of the problem that we are trying to solve. As the saying goes, a picture tells 1,000 words. So point A, if I estimate the x coordinate 1 being here and the y coordinate of 3 being here, the point A is located approximately here. So I'll label that as A1, 3. The point B, if -2 on the x-axis, is located about here, and the point 5 on the y-axis is approximately here, and the point B would be located about here. So I'll mark that as point B, -2, 5. Now for the arbitrary point P, if I draw it here, so P, and it has the arbitrary coordinates x, y, we are given that the distance from PA, so this distance from point P to point A, is twice that of the distance from point P to point B. So if you can imagine that the red and cyan lines are straight, then the red line is twice as long as the cyan line. Now we are given that PA is equal to 2 PB, and the over bars are just to represent they are distances. So if I square both sides, so we have the distance of PA squared, and if I square the left hand side, I have to square the whole of the right hand side. So this gives us PA squared is equal to 4 times PB squared. Alright, now the horizontal component of PA will be given by x minus 1. So the difference between the x coordinate of P and the x coordinate of A, so it's x minus 1. And the vertical component will be y minus 3. So the difference between the y coordinate of P and the y coordinate of A. Similarly, the horizontal component of PB is given by x minus -2, which translates into a x plus 2, and the y component of PB is given by y minus 5. So by Pythagoras theorem, PA squared would be equal to x minus 1 squared plus y minus 3 squared. And similarly for PB, if I leave the 4 out the front, Pythagoras theorem will give us x plus 2 squared plus y minus 5 squared. The next step is to expand each of these terms, and we do that using binomial expansion. So the first term expands to x squared minus 2x plus 1 plus the second term expands to y squared minus 6y plus 9. We leave the 4 out the front. We have x squared plus 4x plus 4 plus y squared minus 10y plus 25. Now let's clean up and simplify a little bit. So we have x squared minus 2x plus y squared minus 6y plus 10 on the left hand side, and if we expand the 4 in, we'll get 4x squared plus 16x plus 16 plus 4y squared minus 40y plus 100. Now let's put everything on one side. So we have the left hand side equal to 0. So this means we'll have 4x squared minus x squared, so this gives us 3x squared. 16x plus 2x is 18x. 4y squared minus y squared gives us plus 3y squared minus 40y plus 6y gives us minus 34y. And we have 116 minus 10 gives us 106. This is the actual equation of the locus, but it's not very helpful because we can't recognize what the shape is. So let's have a play around with this equation. Now if I factor out a 3 and complete the square on the first two terms, so we have 0 equals 3 outside of x squared plus 6x plus the rest of the equation. Now completing the square, we have x plus 3. So if this term is squared, I will get x squared plus 6x plus 9. So we have to subtract a 9, and the coefficient 3 remains at the front. The rest of the equation, let's factor out a 3 and complete the square on the y term. So we have 3 outside of y squared. Now 3 doesn't go into 34, so I'll write it as 34 over 3 y plus the 106 that remains. So completing the square on the y squared minus 34 over 3y term, we have y minus, this coefficient gets divided by 2, so we have 17 over 3. So y minus 17 over 3 squared gives us y squared minus 34 over 3y plus whatever 17 over 3 squared is. So we have to subtract away 17 over 3 squared. And the factor 3 also remains at the front for this term. And for 106, let me write this as 3 by 106 over 3. So copying down, we have 3 outside of x plus 3 squared minus 9 plus 3 outside of y minus 17 on 3 squared minus 17 on 3 squared plus 3 times 106 on 3. So if I divide both sides by 3, the 3 on the right hand side will cancel out. And I can now move all of the free terms to the other side of the equation. So I have x plus 3 squared plus y minus 17 on 3 squared is equal to 9 plus 17 on 3 squared plus 106 on 3. Sorry, this should be a negative or minus 106 on 3. So the numbers are, if I use a common denominator of 9, we have 81 over 9 plus 289 over 9 minus 318 over 9, 52 over 9. So we have x plus 3 squared plus y minus 17 on 3 squared is equal to 52 over 9. So the locus is a circle centered at negative 3, 17 on 3, which is approximately 5.7, and it has a radius of the square root of 52 over 3, which is approximately equal to 2.4. So if I was to draw this, negative 3 on the x-axis is about here, 5.7 on the y-axis is about here, so the center of the locus is approximately here, and it is a circle of radius 2.4. Okay, so that's as far as we'll go with locus. If you have any questions, please use the comments below. And if you have found this video to be useful, please give me a like and please share. And please feel free to subscribe to my channel for future videos that may help you with your math studies. Till next time, best of luck.